Okay, let's find the inverse function of f of x, which is equal to x squared minus 1 on 1 plus infinity. Okay, so if we try to graph the function, let's do it an approximate graphing of this one. Okay, here it should be more dented here. So this is the graph x squared minus 1. Okay, and if we are trying to find the inverse function, it should be symmetric with respect to y equals x. Okay, and it should be a function. But if we do this one, we're not going to have a function unless we restrict our attention to some interval. So we can do it on 0 plus infinity, but we rather do it on 1 plus infinity. Okay, so in this case, we're going to try to see that we're going to define f from 1 plus infinity onto some b that we have to determine. Okay, and the inverse function is going to be from b onto 1 plus infinity. Okay, so we need to find this b. How can we do that b? How can we find it? So to have a function that's to talk about the inverse function, our f has to be injective and surjective. To see why our function is injective, so we need to have, so we set f of x equals f of y, and we try to find a relation between x and y. So if we set x equals to y, any x and y from this interval, so that's a condition that we need to add. So x and y are in this interval. Okay, and we see what we can get. So here, if we said that we're going to have x squared minus 1 equals y squared minus 1. So adding 1 to both sides and factoring, so we're going to have x squared minus y squared is 0. This gives us x minus 1 y times x plus y equals 0. But this gives us x is y or x is minus y. Okay? We can't have x minus y because both of them are in this interval and they have to be positive. So we can't have x is minus y. So this condition requires that one should have the opposite sign of the other. That's why we reject this one, and only one left is x is y. And this proves that f is injective. To prove that f is surjective, we can prove that like here we can see graphically, if we restrict the domain to be 1 infinity, so the range is going to be 0 plus infinity. That's our b. Okay, so let's prove that this one. So given that x is bigger than 1, so x squared is bigger than 1, and this proves that x squared minus 1 is bigger than 0, and this is our y. So y is bigger than 0 for all x's in 1 plus infinity. That means f of a is, for any x that we take, is b, where b is 0 plus infinity. This proves that f is surjective. Okay, so now we proved that f is both surjective and injective on this interval 1 plus infinity unto 0 plus infinity. Therefore, we can talk about f inverse. It's going to go this way. So this is our f inverse. So this one takes x and we get y. This one will get y into x. Okay? But later we're going to switch back and we're going to see y. Okay? So this one is saying us f inverse of y is equal to x. Okay? So to find this one here, we don't have the expression for f inverse. That's the one that we are looking for. But we can write this one as f of x is y. Okay? So let's find f of x, solve, switch x and y, and solve. So f of x is x squared minus 1 is y. So if we add 1 to both sides, we're going to have x squared is y plus 1. So now we take the square root. But given that x is bigger than 1, so x is going to be positive. So x is positive. Okay? So now we have this one here. So we found our x here. So f inverse of y is the square root of y plus 1. Now, since we are we only graph functions when we have x as a domain. Okay, and we can switch back here. We can put x, but x has to be from 0, has to be in this domain. So that's why we put f inverse of x is square root of x plus 1. Okay, if we try to prove this, we can see it graphically here. Okay, so if we try and see here, this is our function, so it's defined here, so this is our f, so it's restricted here on this interval. So if we try and graph the f inverse, it's gonna be on, we said on 0 plus infinity, so it's gonna start from here. Okay, but when f is 0, it's gonna be, so let's have this one, when f is 0, it's 1. Okay, so it's gonna keep going with respect to this one here. Okay, so this is our graph. I don't know how to draw this one, but you get the idea. This is square root of x plus 1. So it's the inverse of this function here. And this is how we do it. So this is how we solve. So we first need, because why are we restricting on this interval? 0 or 1 plus infinity? Because think of it this way. Here, if we have f of 0, f of 1, okay, so f of 1 is 0, and f of minus 1 is 0. When we take the inverse, this function is gonna give us g of 0, 1 or minus 1, but this is not a function unless we work in a domain. Okay, so this is the reason why we have to do it, why we have to restrict it, because otherwise it's not going to be a function. Okay, and to show that f has an inverse, we need to prove two things: that f is injective and that f is surjective. Okay, and the reason why we switch back x and y is here. If we try and see here and see that we have the y's here, so f has the domain, f inverse used to have the domain here and the range here. So that's why we switch back the domain and the range to have the range for both f and f inverse on the same axis. That's why we switch x and y. And sometimes we don't have the expression for f. That's why we don't have the expression for f inverse. We solve for f. Okay? So it's good to review and check these results.